Let's talk about multiplying binomials. So for example, let's start with something like this. So it's called a binomial because we have two terms here and two terms there. So a binomial. And essentially we're going to use the distributive property twice. So we're going to take this and we're going to distribute it to those two terms. Let's do that. So x times x, I'm just going to represent it right now. So x times x, and then x times -3. So x times x is going to be multiplied here, and then x times -3 is -3 times x. So x times x, remember that by these exponential rules right here, when you multiply monomials that have the same bases, so the base here is x, you add the exponent. So x times x, they're secret ones here. So x times x is going to be x squared minus 3x. So that's what we get initially. Now we're going to take this and we're going to multiply it using the distributive property, or the distributive law, if you will. So 4 times x is 4x, and I'm going to put that right here just because they're like terms. I'm going to be adding those together later. And 4 times -3 is -12. So notice the way I grouped that. So x squared is not really a like term with these, because remember, like terms have to have the same letter and raised to the same power. So since this is x squared and these are just x's, they can't all be combined together, but these two can. They're both x's. So my final answer is going to be this right here. So -3x and 4x is just 1x, or I could write x because the 1 is implied there in front of it. So x is the same thing as 1x. So this is my final answer here, x squared plus x minus 12. So that's my solution. Now I do see in some textbooks, let's see, what was that, x plus 4? I have seen in some textbooks, instead of this being written horizontally like this, I've seen them written vertically on top of each other, and it's not going to be any more difficult or really much different. Essentially, we are going to do the same thing. We're going to take this x and multiply it times both of those, and then we're going to take this -3 and multiply it times both of those. So it's essentially the same thing. So x times x is x squared, x times 4 is 4x, -3 times x is -3x, and -3 times 4 is -12. And I'm going to combine my like terms here, and I get the same answer. So this answer is the same as that answer. It doesn't really matter whether I do it on top of each other like this, or whether I do it sideways like that. Now, a lot of people like to call this up here, they like to call it the FOIL method. And FOIL stands for first, outer, enter, and last. So you're multiplying the first terms in each set of parentheses, the outer terms, the inner terms, and the last term. So FOIL. So you see that in a lot of books. I don't love it. What I do love is what I was taught in just the distributive property twice. So the idea of taking this term and distributing it, and then this term and distributing it. I kind of like that better because, I don't always remember what FOIL means, and I don't know that students remember that, but it doesn't really matter. So if you like FOIL, use it first, outer, inner, last. If that helps you, I say use it. If that's complicated, just realize you've got to take each term and multiply it by the other terms in the other set of parentheses. So it works horizontally or vertically to be able to multiply those together. All right, so let's look at a little bit more complicated problem. Let's suppose that we have 2x plus 5. Something like this. So I'm going to take this and distribute it. I like to draw these lines. So 2x times x is 2x squared 2x times negative 6 is negative 12x. 5 times x is 5x. And 5 times negative 6 is negative 30. And then I can come back and combine these together because they're like terms. Now notice this time I didn't write these on top of each other, because you can just write it all out like this and then pick out your like terms. So this is my final answer here. The benefit of writing them on top of each other like this, or even like I did here, is that perhaps you can find the like terms a little bit easier. I just forgot to do that here, and it doesn't really matter as long as you don't lose them and you can pick them out later on. So notice 2x times x was 2x squared, because 2, and this is a 1x, 2 times 1, we're multiplying the coefficients there, and then we're multiplying x times x to get x squared for the reasons I mentioned above. So this is our answer here. Let's do one more. So let's suppose we have 5x minus 3 and 2x plus 1 like this. So I'm going to go 5x times 2x. Well, 5 times 2 is 10, and that's going to be x squared. And then 5x times 1 is 5x. Negative 3 times 2x is negative 6x, and I remembered to write it on top of it, or underneath it. And then negative 3 times 1 is negative 3. All right, so draw a line here. I'm going to combine my like terms. So 10x squared minus x minus 3. So this is a polynomial. It's actually called a trinomial because I have 1, 2, 3 terms that are connected by subtraction signs there. So a trinomial is 3 terms connected by addition or subtraction. And this was a binomial, 2 terms, bi times another binomial. So binomial times binomial combined my like terms ended up getting a trinomial. 1 term is a monomial. So this by itself is called a monomial. This is a monomial. This is a monomial. Altogether, it's a trinomial. So that's a little vocabulary for you. Also, some vocabulary would be, this is called the coefficient. So the coefficient of the first term is 10. So the coefficient is the number that's in front of a term or a monomial. So this is a coefficient, this is a base, this is an exponent. The degree of just this individual term by itself would be a degree of 2. The degree of this term would be a 1 because there's a secret 1 right here. So degree of 2, degree of 1. A number or a constant has a degree of 0. But the degree of the overall polynomial is whatever the largest individual term's degree is. So the degree of this polynomial is a degree of 2 because the largest degree of any individual term was 2. So let's go a little bit further to look at this situation. So the degree of this term is a 3, and the degree of this term is a 0. But the degree of the overall binomial is a degree of 3 because the largest individual term was a degree of 3. So this individual term has a degree of 3. This individual term has a degree of 0. But the overall degree of this is 3 because that was the biggest individual term's degree. Well, I hope this helps a little bit. So you know a little bit about coefficients, degrees, monomials, binomials, trinomials, and multiplying 2 binomials together. See ya.